In this video, I am going to show you how to derive the probability function of a random variable, and in this case, the random variable represents the number of heads and 3 tosses of a coin. Okay, so first let's begin by defining our variable. This is a step that is common to all of mathematics to be sure we know what we are actually working with. So I will use a little marker x equals number of heads in 3 tosses of a coin. So x, our variable, is the number of heads in 3 tosses of a coin, and the question to be answered is derive the probability function. So the first step is let's build a little tree so that we can list the various possibilities that might arise. Let me switch color. So let's see. Let's use light blue. So think about this very carefully now. When you first toss a coin, on the first toss, you have the options of getting either a head or a tail. So head or tail on the first toss. H or T. And this is the first toss. Then you toss the coin again, and once again, you have 2 options as follows. Head or tail, head or tail. Then you toss the coin a 3rd time, and once again, 2 options are available. Either a head or a tail, or a head or a tail, a head or a tail, or a head or a tail, like this. Okay? So these are the various possibilities when you toss a coin 3 times. What might be helpful here is to actually separate these so they're more clear. So these here, okay, these are the first. Okay, so first toss. And these are the second toss options. Second toss. And then these represent the options on the 3rd toss. Okay. So we're tossing a coin 3 times, options on the 1st, 2nd, and 3rd. Now we're actually going to list all of the options in sequence. So the first one says tail, head, head. T, H, H. Okay, T, H, H. Next one says tail, head, tail. So that's tail, head, tail. Then we have tail, tail, head, tail, tail, head, then tail, tail, tail. Then we have head, head, tail, head, head, tail, head, head, head. Okay. Then we have head, tail, tail. Then we have head, tail, head. So these are the options available to us when we toss a coin 3 times. First toss, 2nd, and then 3rd. So tail, head, head. To be sure you can read that. That was meant to be an H, not a T. Tail, head, tail, 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 head, tail, 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 head, head, tail, head, 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 tail, tail, head, tail, head. So these are the options available. And now the question is, in our case, the random variable says the number of heads in 3 tosses of a coin. Well, because it is a variable, we set up a little axis. Okay, so this is our axis. This is our x. And now let's look at the various possibilities. First off, if you get a tail and a tail and a tail, no heads have occurred, which means one of the options is 0 heads. What is the next option? Let's take a look. We can get such things as tail, head, tail, or tail, tail, head, and so on. And the key point is there's only one head present. So 1 is an option, okay, as the number of heads within 3 tosses of a coin. Let's take a look at the next example. You may also have such things as head, tail, head. Tail, head, head. In that case, you have 2 heads and 1 tail. So the number of heads can also take on the value 2. And of course, you may have a head, and a head, which means that 3 as the number of heads is another possible value. So x is the axis here, representing our variable. The variable is the number of heads and 3 tosses of a coin. These are the possible values taken by this variable, 0, 1, 2, or 3. And I got these simply by counting the number of h's and all the choices listed here. And now we have to find the probabilities to go with these. Okay, this is a crucial step. First I will do is draw a vertical axis. Here we are. This will be our vertical axis. Actually, you know what? Let me use black for that. There we are. So, 0 heads means 3 tails have occurred. This corresponds to, let's see what probability. Just count them. The only number of ways you get 3 tails is 1 way out of 1, 2, 3, 4, 5, 6, 7, 8. So here, you would mark 1/8. Okay, I'm going to take each box to be 1/8. So there's a line that looks like this. This represents 1 out of 8. What about the number of ways to get 1 head? Just count them. Okay, just let's tick them off. And here I want to use a different color once again to make things a little more clear. Okay. We've already taken care of the case of 3 tails. That means 0 heads, in other words. So you mark a segment of length 1/8 above 0. And what about getting 1 head? Let's tick those off, okay? Well, this has 2 heads. This has 1 head, so that qualifies. 3 heads, 2 heads, 3 tails, 1 head, that qualifies, okay? That qualifies. So you see that there are 3 of the 8 that have 1 head. So we will mark a segment that is 1, 2, 3. This represents 3/8. Okay? Now, what about the number of ways to get 2 heads and 3 tosses of a coin? So let me choose a different marker. Red this time. So 2 heads and 3 tosses of a coin. That's a possibility. That is a possibility. And that is a possibility. So we see that this occurs in 3 out of 8 ways. So once again, we mark 3 out of 8. And now let's take a look at the number of ways you can get 3 heads and 3 tosses of a coin. That is 1 out of 8. So we mark a segment that looks like this above the 3. This is our probability function. It tells us, for example, that the probability, okay, of getting 0 is 1 out of 8. The probability of getting 1 head in 3 tosses of a coin is 3 out of 8. This is 1 out of 8, 3 out of 8, 3 out of 8, and 1 out of 8. Okay? The probability of getting 2 heads is also 3 out of 8. The probability of getting 3 heads is only 1 out of 8. So this is what is known as the probability function of this random variable, and the random variable is the number of heads in 3 tosses of a coin. And of course, you have to be sure that all of these add to 1. Okay? So if that is not the case, then something is not quite right. So let's double check. You have 1/8 plus 3/8 plus 3/8 plus 1/8. So let's double check here. The new denominator is the same in all cases, so we write it. And then you have 1 and 3, which is 4, 4 and 3, which is 7, 7 and 1 is 8, which is, of course, just another way of writing the number 1. Okay, so it checks. And that's it. Thank you for watching.